So now, bring this guy up. So let's erase what we got so far. Now we're on 4, 5, and 6. So far they look pretty straightforward. Once again, density equals mass over volume. Number 4, the density of the volume of an object. What? The density and the volume of an object are, okay, gotcha, 16.2 grams per milliliter and 55 milliliters respectively. Sorry, I'm dyslexic. Calculate the mass of this object in kilograms. So all we're doing right now, so we need to find the mass. Once again, we do our little magic. V times both sides. Now we got VD is equal to M. However, actually, yeah, that's about it. That's all we need. So mass is equal to density and volume. Doesn't matter if you do volume, density, volume. It's interchangeable. So let's plug in what we got. Let's plug and chug. So we got mass equal to, let's do volume first, which is 55.00 ml. I feel silly putting the 0.00. You don't really need that, but let's keep it. 16.2 grams per milliliters. Boom. So obviously, as you can tell, we're just multiplying here. But let's just focus on the units really quick. So on one of them, one of the parentheses, we have ml, being this guy, just taking away the number. Next parenthesis, we have grams per milliliter. So boom, boom. Grams will be our answer, which makes sense because we want the mass in kilograms. Let's not forget that part, but for now, let's just solve for the mass. So what's 55 times 16.2? Well, the answer to that would be 891 grams, right? 891 grams, but we want it in kilograms. So the easiest way to do this is honestly 1, 2, 3, we're done. Seriously. 8.91 kg, kggi, just like the radio station mass. So that's about it. That's that one. Now let's go to number 5. Mercury has a density of 13.6 grams per milliliter. What volume of mercury must be taken to obtain 225 grams of mercury? All right, let's check it out. D is equal to M over V. Mercury has a density, so we got density. That's the one down. Volume of mercury has been taken to obtain. Okay, cool. So let's fix this up. Now we got volume times density equals mass, but we need volume by itself. So we're going to divide D to both sides. So our new formula is going to be V is equal to mass over density. Perfect. Now let's plug and chug. So we got V over here equal, because that's what we're trying to solve, right? Where mass is going to be 225.0 grams. God, I just don't like writing that. It's just unnecessary. Over 13.6 grams per milliliter, right? So our density, plugged it for that. Our mass, we plugged it in for that. And we're trying to find volume. So once again, let's just do the units on the side. If we have a fraction, we have grams over here, and right below we would have grams over milliliter. Once this would switch, just going back to basic algebra, grams times milliliter over G. These two we cancel out, leaving the answer with an ml. So our answer is going to have this. So normally I just see it, but I mean, I'm going to just write this out just for the sake of educational purposes. Now let me erase this because it makes it look more harder than what it is. Oh, now it's frozen. My computer's like, you're making me do too much. There we go. I have like so many programs running in the background while I'm recording this for YouTube. Yeah, come on, dude. Erase, wasting time. All right, back to this. So now we got 225 divided by 13.6. Volume would equal 16.54 milliliters, because we established before the grams get canceled out, so the answer would be in milliliters. And 225 divided by 13.6 would be 16.54. Why are we keeping 4 numbers specifically? Because we have 4 significant figures right here, 225.0. Perfect. So that is our final answer. Yep, for that one at least. Let me write it down here really nicely. I feel that number 6 is kind of making me feel uneasy just because it's too cubish. It's like Minecraft. Scribble that out. That doesn't mean anything. Last one, number 6. Let me just clean this workspace a little bit. Actually, I could just, there we go. Out of sight, out of mind. So, convert 3 kilograms per liters to grams per milliliter. So, first and foremost, this is what we're doing. Kg over L. We're going into G over ml. That's all we're doing. So, first things first, I want you guys to understand one thing. 1 kilogram is equal to 1,000 grams. You can interchange it, or 1,000 grams equals 1 kilogram. Just remember, these are just conversion factors. This is pretty much what holds people from succeeding in chemistry, just not understanding or memorizing, really. It's just memorization, really, of certain units, just key ones. Same thing, 1 liter is equal to 1,000 milliliters. So now we got our little conversion factors. That's what you call these. In chemistry, we would write it like this. Over 1, 2, 3 zeros. And this one would be obviously 1L over 1, 2, 3 zeros. Boom. So we're going from him. So let's write it. Let's go for it. 3 kg over L times, because we're doing it by that, we're going to have 3. I can just tell you right off the bat, we're going to have 3, just because 1, 2, 3. We're going to do, we got to cancel these guys out. So we're going to do over here kg. We need to cancel out kg. So we're going to do 1 kg, 1 kg, 1 kg to 1,000. Remember I told you? The same way these can be interchangeable, these can be interchangeable. You feel me? Like they can be switched up and down. I don't know if it makes a difference to you if I put an arrow, but yeah, basically they can be interchangeable. So on the top we have 1,000 grams, right? Nothing crazy so far. So next, right here, this has to do with this guy now. So this conversion factor, sorry, this part of our step has to do with just the kg on the numerator of this little fraction thing. Now we have to do the liters. Liters are in the bottom of the fraction, so we're going to put it up here. We're going to put 1L, and then obviously, as you know, just like this. Sounds good? And actually, maybe this would help you see it better. Because I know not everyone, you know, sees everything the way it's supposed to be. And over L. You can actually write them this way. I do the slash because I understand it, but if this makes it easier. So now look, kg on numerator, kg on the denominator. It's gone. L on the bottom, denominator, L on numerator. It's gone. Now, all we have is 3 times 1,000 grams divided. Now, it's not times. I know it's, you're like, wait, isn't it multiply? Yeah. If anything on the numerator, you're going to multiply straight across. Anything on the denominator, you're going to divide it. But really what happens is you're kind of doing this. You're kind of going like this in a way when you're doing the math. I know it's kind of weird, but that's really what we're doing. So 3 times 1,000 is 3,000. Divided by 1,000, we're back to 3. But now remember, these guys didn't cancel out. We got milliliters, we got grams. So 3 times 1,000 equals 3K, or 3,000. Divided by 1,000 again is just 3 again, right? We undid what we just did. So grams per, because grams is on the numerator, and the denominator, the only thing left that's not canceled out, milliliter. Boom. And look, that's what we wanted. So easy peasy, lemon squeezy, we're done.